DRSD 2021's Technical Session 14, Critical Infrastructure Resilience 2. My name is Luis Arboleda and I am the Zoom host for this hall. The rapporteur for this session is Ms. Hun Kang. A few reminders before we start. This Zoom session is being recorded. The recording will be made available upon request. If you have any objections, kindly inform us in advance. There will be a total of 9 presentations in this session. A technical session chair will be announcing each presentation and respective presenter. The discussion and Q&A portion will be held when all 9 presentations have ended. We would like to request the presenters to keep tabs on the chat box and answer any questions directed to them. If not, we may address these questions at the end of the session. Now, before we proceed to the presentations, it is my privilege to introduce to you the technical session chairs. First up, it's Dr. Iftikhar Ahmed. He is an associate professor and previous program convener of the Master of Disaster Resilience and Sustainable Development, University of Newcastle, Australia. He teaches policy and social aspects of disaster risk reduction, resilience of the built environment, and sustainable development. His research interests include post-disaster housing, disaster risk reduction, climate change, adaptation, and urbanization in the Asia Pacific. Next, Dr. Indrajit Pal. He is an assistant professor and chair in the Disaster Preparedness Mitigation and Management, Asian Institute of Technology, Thailand. Dr. Pal, having more than 18 years of experience in research, teaching, training, advocacy, consultancy, primarily focused on disaster risk governance, hazard and risk assessment, risk perception, CBDRM, public health risk, GIS and remote sensing in DRM, public health risk assessment, and climate change adaptation. Let us welcome our co-chairs.
Yes, good evening. Thank you very much for your introduction. I believe Indrajit is going to join us soon. Can you hear me? Hello?
Yes, we can hear you.
Yes,
we can hear you.
Okay, I can see Indrajit has joined us. So good evening, everyone. So I guess we can start, and I think this just is a little bit of introduction to what we're going to discuss now, is that it's about critical infrastructure, and I think everyone here is savvy enough to know what critical infrastructure is, and particularly its relevance to disaster resilience. And I see that there's a good mixture of all kinds of infrastructure-related papers, spanning from solid waste management to road infrastructure. So I think let's just go into the papers and then we can have a discussion. And now if you have any questions, put them in the chat box. The best way to do it is that at the end of the session, we'll have some time left, I believe for about 15 minutes or so, when we'll get the respective presenters to respond to the questions or even comments. And is that all right, Indrajit, with you? Would you like to add anything before we start off?
No, thanks, Kiti. Thanks for joining. I know you are very busy with your present assignment with the university. So thank you so much for joining us. So maybe we can go one by one presentation and we will play from our side. So if you are okay, then maybe we can go ahead with the name of the sessions and the presenter names. So we'll play accordingly.
Okay, that's great. Thank you.
Yeah. Okay, I'll be standby here.
Morning, professor and friends. I would like to present the topic Excellent Modulus of Municipal Solid Waste Bottom S in Vietnam. My name is Nguyen Châu Lan from University of Transport and Communication in Hanoi, Vietnam. First, I would like to introduce to you about the municipal solid waste generation. You can see in the right picture, it's about the waste generation in Hanoi, and it is about the 300 tons per day for the waste generation in Hanoi. And you can see the bottom picture is about the landfill site in Hanoi. The name is the Namson landfill, which can receive and process daily about 3,800 to 4,100 tons. Recently, the incineration is applied for MSW treatment in Vietnam. Previous research shows that the MSWI bottom mass can be utilized for road embankment, base, and subway. However, there is limited research on the cyclic behavior of MSWI bottom mass. So that's why we will focus on the cyclic behavior of the bottom mass in this research. And for the methods, we will collect the sample from the bottom mass isolation ice, and we conducted two kinds of tests, physical tests, such as the water content and specific gravity. And also, we conducted the mechanical tests, such as the compression cyclic pressure test. And this is a physical property of municipal solid waste insulator bottom mass. You can see the particle distribution curve with a percentage of finer and diameter, and we can it is the distribution curve you can see here. And also we have the water content of the bottom mass about the 25% and specific gravity about the waste sample of the 2.64. And we can classify, well, according to USCS, is a sand well with the sand well graded. And with using the XRD and as SEM, we can estimate the micro property of the municipal solid waste insulator bottom mass. You can see here is the XRD test. We have the POC and the CaCO3 is the main component of the sample. And you can see the SEM image, the raft in the surface of the sample. It means the sample view is higher in the compression and higher potential of the strength, such as the compression and the pressure angle of the sample. We conducted the Zeppelin modulus of the for the MSW bottom mass. First, we prepare the sample and we compact the sample into the charger mold with a diameter 7 centimeter in diameter and the 140 centimeter in height. We compact with the water content, maximum water content, and the basis for the 30 and 35 of the maximum dry density. The picture shows after finish the compression, we have the sample and we have the two porous stone and we put the sample into charger cell. And according to the ASTM 307 standards, the name standard is a standard method of test for determining the MR of the soil and the aggregate materials. We conducted with the subsequency of from the 1 to 15 and the confining pressure sigma 3 here, and we have the maximum actual stress, and also we have the given of the number of the load cycle, and for the one cycle for 1 second we have the 0.1 second for the increasing the load string and 0.9 second for the cover duration, and it is control of the charger test sample is something like that. And why we need to conduct the resonance modulus of the sample here we have we will using the bottom mass for the road embankment. So we had to conduct the test to make sure the sample is good. For example, if we conduct the test and we get the value of the MR, and if the MR is larger than the 120, it means it's a good material for using the for the road construction. And here I will show you how the machine working. It's apply the cyclic, and it's a chaser test. And we have the cell pressure, and we have the deviator stress here. And it's the sample under the construction, under the testing. And for the resource, we have the Zeppelin modulus of resource. Picture 4 and picture 5 is the Zeppelin modulus of the waste MSW bottom end sample for the 90 and 95 compaction. And we have here we have the three different confining pressure: 41, 27, and 13 kPa. And we have the resource of the Zeppelin modulus, and we can see is a fraction is a chain of the Zeppelin modulus according to the deviator stress, and also the changing of the Zeppelin modulus according to the axial chain. And we have the two cases from the 19 and 95 of the compaction degree. And the picture shows that the Zeppelin modulus versus the axial chain for samples at the R19 and R95, especially axial chain of the 0.1%, the Zeppelin modulus of the two sample is the highest value for the both R90 and R95. And we move to the discussion. You notice that the highest values of the often both sample at the beginning of the cyclic chaser test. The behavior of the 90 sample is different from that 90 sample. The Zeppelin modulus increase with the increase of confining pressure and decrease with the increase of the deviator stress. And the highest value of the MR is approximate 110 MPa for the cell pressure of the 41 kPa, while the lowest value is MI is about 20 MPa for cell pressure of the 13 kPa. And the similar behavior was found for the consent soil material for the subway material reported by Rahim in 2005. And for the conclusion, beyond the experimental resource, the following conclusion can be drawn. First, in the case of the 90 samples, the MR value decreased to some extent before is fluctuated and partly reduced when the deviator stress increased up to 90 kPa, 70 kPa. In the case of the 95 sample, the Zeppelin modulus increased with the increase of the confining pressure and decrease with the increase of deviator stress. It is recommended that the MSWI bottom edge can be used as a construction materials, such as road bed and foundation layer. And finally, thank you very much for your kind attention.
That's great. Thank you very much. It's a great presentation. I think what you have highlighted is quite important, that you can actually use waste materials for practical use. I do have a question, but we can come back to the later. What is the cost benefit analysis that you may have conducted, whether it is, and I can believe it is cost effective, but what kind of benefits does it have over more traditional, more prevalent kinds of building materials for road construction? But let's leave it with that, and that's a great presentation. So let's move on to the next one. Thank you. Indrajit, do you want to add anything, or are you okay for us to go on?
Let's go on.
Okay, great. Thank you.
And one quick announcement to all participants. So please do write your questions to the Q&A part in the chat box for the respective participants, respective persons. So mention the name. So the presenter can respond by writing, or they can come back live after the session is ended. The presentation is ending. Yeah. Please go on.
Thank you.
Hi all, myself Ravindra. I'll be briefing you on seismic behavior of pavements, approach towards seismic resistant design of roads. Roads are lifeline for the developing and developed countries, which plays a major role in economic development and emergencies like war and relief operations. Because roads serves as critical lifeline in the delivery of basic daily needs, they need to function even in the face of adverse weather and natural hazards. Natural hazards like earthquake often triggers other devastating events such as landslides, fires, and lateral spreading, which is essentially due to soil earthquake caused soil liquefaction. And in addition to destroying buildings, earthquake can damage bridges and pavements and other components also. And if an earthquake occurred in the ocean, it can trigger a tsunami, and that can cause a devastating effects to the nearby coastal areas in terms of road, bridges, and other property losses. In picture 1, we can see a figure of collapsed highway interchange between the section I-1 to I-14, which has occurred during San Fernando earthquake in California on 9 February 1971. The other recent pictures of collapsed roads due to earthquakes are shown in figure 3, which has occurred during the Indo-Pakistan earthquake, which is on September 25, 2019. Figure 2 shows an image of Japan earthquake in the year 2001 and the pavement damage caused due to that earthquake. In both the figures, we can see that these roads are failed essentially due to lateral spreading of the soil beneath the pavements. The other major earthquake which has caused significant damage to the pavements are Sikkim earthquake in the year 2011, Kashmir earthquake 2005, Bhuj earthquake 2001, and Nepal earthquake 2015. So we have taken this study to get some idea about seismic behavior of pavements, how it will behave. Our research backgrounds are like in the year 2011, and Glasgow has made an attempt to propose a new RDS scale to classify and quantify the road damage caused due to earthquake based on data collected from the major earthquakes in the past from worldwide except India. As we know that MSWI scale is extensively used to measure the earthquake intensity which is based on damage caused to building, accounting site and induced site effect. But this MSWI scale is not suitable to measure and quantify that the damages caused to pavements due to earthquake. Hence, this RDS scale model is very significant in this aspect. In our study, we have carried out the FEM modeling and the material property and geometry of the pavement and embankment is taken from Huang et al. 2004 and Tang 2001. We have that mesh confinement study has been carried out in order to get the most stable results. And that height of impact, the geometry of embankment is such that we have taken that height of embankment as 10 meters and the width of the embankment is 6 times the height of the embankment, and the side of the embankment is vertically fixed and that base of the embankment is fully fixed, whereas 3 layers has been considered in the case of pavement. Three different layers have been considered with the application of load Q. In the base of the pavement, in the middle, we have applied the harbor sign loading to take into account that seismicity. Initially, we have considered only 10 meter embankment to study how it will behave under the seismic harbor load. But we have found that is using two different softwares, we are getting almost the same result. So the validation of model is very good in this aspect. But in the next section, we have taken that effect of pavement layer also, and 3 points have been considered as a point of study, as we can see here. Point C, which is a crest, point D, which is a 2, and point I, which is a far field effect of the embankment under study. As we can see, as we go far from that crest to far field point, that effect of that acceleration in the acceleration time history shows there is a decrement in the acceleration, whereas that effect of loading is negligible here in this case. And for q equals to 0 kPa and q equals to 100 kPa, that effect is, there is no effect on acceleration time history, and it gives almost the same result. The next section, we have considered that loading and the pavements also. Three different layers of the pavement also. What we have observed that with respect to depth, after 7 meters, with respect to depth of the embankment after 7 meters, there is a significant variation in the acceleration of the layers. And we have observed that with increasing static load, that is from 0 to 300 kPa, there is an increase in acceleration, and which is maximum for q equals to 300 kPa and minimum for 0 kPa. So from our study, these conclusions can be drawn, like the comparison of acceleration versus time history using deep soil 1D and another study shows a reasonable result. The maximum seismic acceleration found at the crest of road embankment, and as the distance increases, the PG of the ground motion decreases. The amplification increases due to presence of pavements. As the traffic load increases, the PG of the motion increases within the pavement depth. Further increment PGA bound at the base of the pavement, which has been approximately 3 times of the pavement width at the surface. These are the references that we have considered. Thank you.
Thank you. That is great. Look, we need to move on very fast because some of your presentations are longer than 8 minutes, and we have roughly a bit more than 20 minutes. So I think let's just carry on. Is that all right? Thank you.
Yeah, thank you. So our next presenter is Mr. Janta. So it's also interesting presentation. Investigation of the landscape of energy resilience research using bibliometric analysis, literature review type of analysis, but it's interesting. I think you'll get a good insight. So let's go through the presentation.
Hello, everyone. My name is Pitpong Janta, one of the participants of this conference. I'm going to present a joint research between National Energy Technology Center and Conceptual University on the topic of reinvestigation of the landscape of energy resilient research using bibliometric analysis. So let's go what we have done. The word resilience has been recognized and believed that it's going to address a major problem that was facing, but the common definition is not really exist. To ensure that scholars researching within the same arena to the common understanding of energy resilience is needed, even though scholars have made several attempts to define the energy resilience to have common ground for the discussions, consensus has not been reached regarding to the common definition, even though some of the definitions have been frequently used. For example, Rose et al. In 2014, they found that resilience involves the actions to prepare, adapt, absorb, and recover. Another one is Gatto and Draco in 2020. They used the text-based bibliometric analysis to conduct and proposed a taxonomy of energy resilience by going through 41 publications and have found seven approaches and strategies, but it not really cover all of the landscape that scholars have been trying to researching with. So the objective of this study is to reinvestigate the landscape of energy resilience with the larger dataset using a systematic tool and methods. The bibliometrics, we are also further to use the bibliometric analysis. It can construct analysis for citation-based datasets, which is the outcomes can include the important keywords in the field, research themes, most pronounced author and institution. Previous study has been used this method too, for example, manufacturing and as well as the energies. Bibliometrics is open source tool for performing a larger data set, sign mapping analysis of the treasure. So it can do something like data gathering, data filtering, data analysis, data visualizations, and it supported several citation data sources, for example, Scopus and Web of Science. So to determine and collect the data set, we're trying to retrieve the target by determining several search terms and using three main keywords, including energy, electricity, and resilience. So the search term include three of these. The first one is energy or electricity and resilience in the energy domain. In the second one, energy or electricity and resilience without the area filter. And the last one is the resilience in the energy domain. We're trying to collect citation information and bibliographic information, which is we receive several thousands of reports, and the historical records is between 2011 and 2020. The method that we use to analyze the data sets are totally four analysis methods to capture the landscape. The first one is the word cloud. It visualizes the occurrence frequencies of keywords using the size. The second one is word growth. It visualizes the changes over time of the occurrence frequency of the keyword. The third one is the MCA. It visualizes associations among the keywords and group them into the cluster. The last one is the thematic map. Is categorize keywords into cluster and reflect them into theme based on density and centrality of the clusters. So one of the search term results of word clouds is you have seen that along with the resilience, there are several keywords that has a number within. For example, microgrid, climate change, smart grid, and sustainability. For the word growth, there are several keywords existing in the sharp increases. For example, microgrid that has the same piece with the resilience, the climate change, and the sustainability. For the MCA, there are several clusters in color. For example, blue cluster, they are identifying several various technologies and the technology management terms. The red cluster, they involve concepts that's relevant to the resilience. The thematic map, there are several themes that have been existing here. The motto themes or the theme that the scholar that have been driving these keywords inside. For example, sustainability, microgrids, distributed energy resources, or energy storage. The niche theme that the theme that the scholar have been developed but hasn't been but hadn't received a degree of importance. For example, climate change and renewable energy. Uh, from the results above, we also have done author search term and combined it in the landscape here on your left hand side. We found that several keywords are identified. So for the landscape of energy resilient research, key topic within the landscape should be this: climate change, sustainability, distributed energy resources or microgrid, and smart grid. So this landscape can facilitate communication among stakeholders in various domains and ensure promotion of climate change and sustainability on energy resilience. And this is the end of my presentation. Thank you for your attention. I will be happy to take any further question that you have. Thank you so much.
Excellent. Thank you very much. I think we can carry on to the next one. It's a great piece of work. So thank you very much.
Yeah, we have next one will be Mr. Malik. So we are skipping one because we have not received the presentation from Mr. Duan. So this next one is like a conceptual framework for identifying the risk of infectious disease transmission during rapid onset disaster evacuation. It's quite interesting actually in the context of COVID. So let's listen.
A very good day for all of you. I am Malik Senivratna, a second-year postgraduate student attached to the Global Disaster Resilience Center, University of Huddersfield, United Kingdom. This research includes the literature findings and the conceptual framework of my PhD research. Title is a conceptual framework for identifying the risk of infectious disease transmission during a rapid onset disaster evacuation. A literature review based on the lessons from COVID-19 and the theories of network centrality. The research is co-authored by Professor Dilanthi Amaratunga and Professor Richard Hyde. The COVID-19 transmission, or the means of passing on the disease from person to person, is caused by respiratory droplets in close contacts. Therefore, as a major preventive measure, physical distancing related restrictions and guidelines were imposed in all parts of the world in different scales. The research studies have proven that the higher level of travel restrictions imposed in wider geographic extents can control the transmission of the virus in significant levels. This ability of the disease to spread is measured using the R reproduction rate. Research have identified that the cities where highest number of R rates were recorded are common to have high-density community agglomerations with high mobility patterns. Usually, high mobility patterns are found at cities where road network connectivity is recorded in high values. Therefore, the network connectivity can be considered as one of the factors to influence the transmission of COVID-19 or any other contagious disease. As the world was battling against COVID-19, what we can identify is that all disaster events are followed by a sudden spike in the COVID-19 cases during the post-disaster period. Therefore, as far as the pandemic outbreaks are considered, rapid onset disasters can be considered as a high conflicting and high-risk associated scenario as there are no proper guidelines available. As a novel response to the integrated hazard situation with COVID-19, the first ever official response release was the guidelines for tsunami warning services, evacuation and sheltering. It clearly explains that a tsunami evacuation order should take priority over a COVID-19 stay-at-home order. During this period, fortunately, we have not experienced a tsunami amongst the pandemic. However, the other disasters during the pandemic explains the probable situation. It is questionable as it generates compatible environments for the pandemic. The compatible environments mean rapid and mass movements and confined community gatherings during evacuation which compromise the physical distancing measures. Where does it happen and how? Most of the aforementioned disaster situations are followed by the general evacuation proceedings, which is aimed at guiding all affected persons towards safe places irrespective of the pandemic condition. In tsunami evacuation, it mainly considers the deterministic tsunami wave height and the estimated lead time for the first devastating wave. Therefore, a different strategy to incorporate a pandemic situation in this evacuation planning should be introduced. However, static evacuation routes with predefined options have deprived adaptive pandemic preparedness in the evacuation process. Therefore, the evacuation planning process should be improved using a connectivity-based approach because the connectivity can identify the risk of internal and external impacts from other hazards such as pandemic and identify the critical routes in the evacuation plan. What we can observe in the literature is that the guidelines on disaster response, particularly on evacuation, conflict with the guidelines on pandemic management. In particular, pandemic management measures consist of the global strategic objectives including controlling the community transmission through physical distancing measures. In contrast, the current evacuation guidelines are set to promote concentrated and confined evacuation, mainly considering the convenience for rapid response. This can cause to increase the risk of disease transmission and the efforts to contain COVID-19 or an infectious disease can be compromised. Therefore, identifying the relationship of COVID-19 or an infectious disease transmission during evacuation is a significant need in the current identified guidelines. Therefore, to address this research gap, the COVID-19 transmission pattern can be studied over a simulated evacuation model for a rapid onset disaster situation and identify the potential relationships. For this, a connectivity-based approach can be considered as a potential way forward because connectivity has been a long-used successful analysis in the transportation planning. Both evacuation and transmission of an infectious disease demonstrate similar behaviors with connectivity, and non-pharmaceutical and mobility studies are recommended for monitoring pandemic and to build integrated response plans. Accordingly, the research aims to identify the elements affecting the transmission of an infectious disease during evacuation for developing the framework for planning safe tsunami evacuation clusters. The framework focuses on improving the preparedness of coastal cities with a comprehensive tsunami evacuation mechanism for pandemic situations. An integrative literature review approach was used for developing a new framework and perspectives on the topic. The key findings of the literature review were studied in a content analysis using the open source based Gephi software to identify the key components for the conceptual framework. The results were incorporated into the conceptual framework to facilitate the pandemic risk assessment during an evacuation operation following 3 phases, focusing risk identification, risk assessment, and risk management. Research have showed that the weighted connectivity analysis can identify the strongly and weakly connected parts of the network and can be used in the road network risk assessment. Node centrality as an analytical method of connectivity can represent the risk of a given node based on the geometric positioning of the network. The node properties can be weighted in combination with the tsunami risk parameters such as exposure, vulnerability, and disaster preparedness. By integrating the simulation of evacuation with COVID-19 R data, the hotspots of pandemic outbreak during evacuation can be predicted. Accordingly, the nodes can be ranked based on the value of risk to develop a clustered evacuation strategy for the areas identified with high pandemic risk during an evacuation process. In conclusion, the framework is expected to utilize a connectivity-based approach for the tsunami risk assessment during a pandemic outbreak, which can facilitate a potential approach for planning clustered evacuation routes. Accordingly, following recommendations can be proposed. A modeling approach can provide rapid and accurate results to identify the high-risk routes for evacuation. Pandemic and centrality studies can be used as an integrated modeling approach for the tsunami risk assessment during pandemic outbreaks. Planning clustered evacuation routes horizontally and vertically can minimize the transmission of the infectious disease among evacuation clusters. One of the major limitations of this study is that the impact of tsunami evacuation amongst a pandemic outbreak is studied based on other similar instances since there are no empirical records and there can be extreme scenarios which are not captured in the method. Let's all be prepared to safe response and prevent unnecessary consequences. Thank you very much for your attention.
Thank you very much. Let's move on. I'm a bit concerned about the time. How are we going for time? We only have about 4 minutes left for this session. And we have 5 more presentations. How do we go out? Are we flexible to continue?
No, it ends at 5:15. We have 1 hour.
No, I think I think we have time. I mean,
We have time?
yeah.
1 hour.
It's 17:15 is the end
Oh,
time.
I see. Okay.
Plenty of time, yeah. We have
Okay,
plenty
that
of
is
time.
good. Okay, let's go on then. Okay, thank you. Let's carry on to the next one. Thank you very much. This is a very interesting presentation. I think it's transferring the DRR knowledge to the new COVID pandemic situation, and we can talk a lot about it. It's good. Thank you very much.
Thank you. So the next presenter will be Mr. Tariq. So he will be describing about the seismic fragility assessment of local load-bearing soft brick unreinforced masonry piers. So can you just go through the presentation?
I am Sagrcha from Southeastern University of Sri Lanka. Today I am going to present about an integrated and adaptable critical infrastructure resilience assessment framework for earthquakes. It's been obvious that critical infrastructure resilience assessment should be carried out in order to provide the serviceability and functionality of critical infrastructure, critical services during the hazards, but in this study we focused especially on the earthquakes. So the scope or the aim of this study is to critically analyze the existing frameworks and from that develop the integrated and adaptable framework in order to support the center framework which is proposed in the 2015. So as an objective, there are 3 main objectives. The first is this systematic literature analysis, and the second one is analyzing the existing indicators and variables in order to support the proposed framework. As a final step, develop the integrated and adaptive framework in order to assess the earthquakes. So in this figure, the performance-based resilience components of the physical or the critical infrastructure system has been shown, which is adapted from the past studies. So it's been obvious that the earthquake occurrence time is quite low. That's the reason why during phases shown shorter. At the same time, ABC type of graphs are especially showing the sudden or the intermediate as well as the progress failures criteria. Also, the alpha and beta type of graph is showing the restorations or the regeneration concept which is proposed in the UN guidelines. So methodology was carried out using the Scopus database as well as Prisma flowchart. As a first step, Scopus database was used to retrieve the appropriate journals and articles with the limitation of engineering and English language based articles. Consequently, 228 journals was selected by reviewing the abstract as well as the title of the particular study and the scope of this study. Subsequently, 43 multi-hazard based framework was chosen as a final step. 24 earthquake based framework was used in order to progress the further study. Critical infrastructure resilience framework in this study especially focus on 2015 to 2021 recently published articles. It's obvious that 2020 has more numbers of articles in order to study the novelty and the new type of proposed frameworks. Also, the critical infrastructure such as transportation, water, electricity, power, and telecommunication was included in the study. At the same time, houses and buildings was studied in order to check the structural integrity of the critical infrastructure, such as hospitals and the schools that will come under critical infrastructure service providers. But you may have a question that why we include 2015 to 2021 articles. It's the reason that Sendai, in order to support the Sendai framework, which is published on the 2015, and from the 2015 to 2021 articles was used to conduct in this study. In this table, the summary of 21st study with respect to different kind of framework tools or techniques that has been used by different kind of scholars is shown. So it can be seen that decision-based, damage-based, as well as the fragility function, also the probability-based model were used considerably higher than the rest of the tools. Also, well known for concept index-based, also the conceptual model were used by some of the scholars. And also the some of the scholars, especially the Kames, were used around four kind of tools in to produce the decision-based framework for the earthquake analysis. Also, the fragility function has used in order to evaluate the structural integrity of the critical infrastructure. So, in the phase of indicators analysis, it's been done using Word IJ as well as GPy softwares. In the first step, 140 indicators were chosen from the past study, and it's been screened and characterized into 24 major type of indicators. For example, seismic specification include the seismic intensity, PGO, peak ground motions, as well as the occurrence of the earthquake. In order to explain this figure, for example, if we take the restoration, the restoration connectivity can be obtained from the infrastructure specification as well as the hazards. The key attributes of analyzed framework can be seen in this figure. It's divided by different kind of phases with the serviceability or the functionality of critical infrastructure with the indicators. So typically it can be seen that in the post disaster phases, especially focus on the long term and short term, also the damage assessment models. At the same time, in the pre-disaster, it is typically focused on the mitigation strategies as well as the interdependencies of the critical infrastructures. Also, during the disaster phase, especially focus on the emergency attributes as well as financial backgrounds of the particular regions or particular country. Also, the as indicators, travel time or the system performance were conducted from the past study, and it's been used in order to propose our novel framework. Summary of this critical review, the proposed framework is shown here. The first post-disaster, pre-disaster, as well as during the disaster context with the serviceability and functionality attributes for analysis. Also the outcomes such as performance indicators, disaster response preparedness, also the short and long-term restoration and regeneration such was proposed. Also, due to some ethical reason, this in progress in the international journals, so that's the reason why actual framework cannot be shown for the ethical reasons. Thank you.
Thank you. Thank you very much. Very interesting presentation, very comprehensive and thorough review. So I think we can move on to the next one, which is Indrajit. You can announce it.
Next one is also interesting and almost very much aligned with the critical infrastructure as well. So it's about an integrated and adaptable critical infrastructure resilience assessment framework for earthquakes by Mr. Sutasan.
Hello, greetings everyone. I am Tariq Anwar Aqib, doctoral student at Gulf, Saudi Arabia, and I'm here to present the work carried out by me and my co-authors, Professor Jayaprakash Vimari and KVL Subramaniam, which is seismic fragility assessment of soft brick and reinforced masonry piers. Moving towards the outline of the presentation, First, I'm going to mention about the motivation and objectives of the study, followed by which I'll give a brief description of the methodologies adopted and conclusion of the study. So moving towards the motivation, as you are all aware, there are 4 seismic zones in India, which are determined based on the PGA values of the maximum considered earthquake that can occur. Now, high seismic hazard when coupled with high exposure of unreinforced masonry structures give rise to high level of vulnerability. Now, most of the building stock, that is around 70% in India, is load-bearing masonry, and this these type of structures are highly vulnerable to damage. The images show some of the damages that have occurred to masonry structures because of earthquakes. So the objective of the study is to assess the vulnerability of the non-engineered unreinforced masonry piers made with soft brick using the 2001 Gujarat earthquake for scenario-specific assessment. Now, for this, we first generate the surface level synthetic ground motions for the magnitude 7.6 Gujarat earthquake, and then we numerically model the soft brick and reinforced masonry piers for different aspect ratios and axial stress values. Then we assess the seismic fragility of these unreinforced masonry piers. Now, first looking at the looking towards synthetic ground motion generation, we require synthetic ground motions because we usually lack recorded data, especially in near field region. For example, for magnitude 7.6 Gujarat earthquake, there are only 13 PGA values available. Hence, we use synthetic ground motions. Now, in this study, we use the modified stochastic finite fault method to generate synthetic records. So this method has 3 key steps. First is the earthquake fault plane is divided into smaller subfaults. Now each fault is treated as a single source radiating seismic energy, and then finally the entire time history is computed as the summation of the response of these individual subfaults. So the only way by which we can verify our simulated ground motions is by comparing it with recorded data. So here in the table we have recorded PGA values for 13 different sites and the PGA values corrected to site classes B and C. And these two are the PGA values obtained through simulations. And finally, we have the residuals between the recorded and simulated values. As you can see that the residuals is comparatively lower and most of them are close to zero, indicating that the simulations match well the recorded data in terms of PGA values. Finally, we generate 30 ground motions at each site using a stochastically finite fault method discussed before. Now, moving towards numerical modeling of soft brick unreinforced masonry piers. Now, soft brick unreinforced masonry. This is a type of masonry where the strength or stiffness characteristics of brick is very less compared to that of mortar. For example, in India, the strength of clay bricks varies from 3 to 20 MPa. Now, this is due to because of lack of automation in production process, use of kilns at lower firing temperature. So for modeling the masonry, we use the micro modeling approach in which the brick elements are modeled as continuous elements, and the interaction between brick or mortar and mortar elements are represented by interface elements, and these elements facilitate the stress transfer between the brick units. Now first, we validate our numerical model by using the observations of Science Umang 2019. So here is the backbone curve traced out by them and the backbone curve traced out by a numerical model, and you can see a good reasonable match between the experiments and numerical model, and the photos here represent the cracking observed for the experimental and the numerical model. Now we perform a parametric study to observe and quantify the effect of axial stresses and aspect ratio on the failure modes of unreinforced masonry piers. So we vary the axial stress by using 3 values, 0.1, 0.5, and 0.75, and aspect ratios for different values. And we observe 3 different failure modes: sliding, flexure, and shear. To identify the limit states in each of these failures, we plot the monotonic pushover curves for these failure modes. So in sliding failure, we see that first there is some onset of flexure cracking, followed by sliding, and then at 4 mm there is loss of bond resulting in collapse. For shear wall, we again see some onset of flexural cracking very early, then we see onset of diagonal cracking, and followed by failure, for which the diagonal cracking extends over a larger part of the wall. Then for flexure wall, we notice the failure in form of toe crushing or rocking of the wall. Now, here is a failure matrix that we were able to build on by using different values of axial stress and aspect ratios. So first sliding failure followed by shear, and then flexure dominating for higher aspect ratios. Then looking at the seismic fragility assessment. So here is a framework developed by us for carrying out the fragility analysis. First, we simulate the response of 10 soft break and reinforced masonry pure samples, and we also generate 10 earthquake ground motions for each PGA level, and this will give us 100 nonlinear time history analysis, and using this we can develop the collapse fragility and calculate the performance of the structure. And we quantify the uncertainty in pier capacity by pairing all the input parameters by 20% to examine their individual influence on the monotonic pushover curves. We observed that there are three parameters which affected the response of shear walls the most, five parameters for sliding, and only one parameter for flexure pier. Now, we use the Latin hypercube sampling, which generates the random realizations of these input parameters. For example, for bed sliding pier, we have 10 realizations of 5 different input measures. Similarly, we have it for diagonal shear cracking as well. Now, values from Latin hypercube sample give us different monotonic curves for different failure modes. So from the time history analysis, we were able to generate the fragility curves first for cracking and then for collapse. So here we do not see much difference between the different types of walls in terms of fragility analysis, but in terms of collapse, we see that three walls vary significantly. With flexure walls were able to resist a higher load compared to the other two walls. Now we were also able to quantify the ground motion and capacity uncertainty. So we observed that the ground motion uncertainty, which is represented in terms of the covariance of the pure displacement, is far significant than the capacity uncertainty found in flexural walls as well as shear walls. So as a summary, ground motions are generated at surface level for various towns of Gujarat. Then we employ micromodeling technique to model the response of soft brick walls, and then we observed that the aspect ratio and axial stress significantly affect the type of failure, and we developed a failure matrix as well. Then uh, we carried out we developed a framework for seismic fragility analysis, and we used the Latin hypercube sampling technique to account for uncertainty in pure capacity. Then we observed that unreinforced masonry piers are highly vulnerable under ground motions expected in the region, and the order of fragility of these piers is that the sliding walls fail first, followed by shear, then flexure walls, and cracking limit state is reached for very low PGA values, and at PGA of 0.1 G, 90% of bed sliding and shear walls collapse. The effect of uncertainty due to variation in capacity is very low compared to the uncertainty due to variation in ground motions, which was calculated from the variance of the pure displacement. And finally, thank you.
Thank you very much. It's a very thorough piece of study. I think this is very applied. I think you can just apply it because as things progress, we may have to move away from brick construction earthquake-prone regions. It's simply, that's not the way to go, or reinforced brick maybe. So just by brick itself is not going to withstand those seismic lateral forces. So, right, can we go on to the next one then, Indrajit, unless you want to add something, any comments?
Yes, I mean, I think we are writing few comments also. Maybe we will come up in the end with this. Thank you. Thank you so much, Tariq. Our next presenter is Gina Acharya. The topic name is like WASH system in developing nations and evolution framework for institutional resilience.
Hello everyone, I am Gina Acharya and I will be presenting my dissertation work for Masters of Urban Infrastructure curriculum at CEPT University, guided by Dr. Mona Iyer. The study is assessment of institutional arrangements for WASH systems demonstrated for case study of Ahmedabad, which investigates into institutional resilience for a city in India. If we look at some background, equitable and sustained access to water and sanitation services is a global challenge reflective of these numbers. The environment today is highly susceptible to disaster risk caused by climate change, population growth, and increased water demand. The global climate risk index also conveys that 90% of the climatically affected countries are middle income and low income countries. This demands bringing focus to developing nations, as climate resilient infrastructure is even more important for them to thrive economically. When there is an additional layer of disaster risk on the underlying adversities, the challenges are even more aggravated. Hence, there is a requirement of proactive action rather than reactive measures. For this, we need to look at the sector in a systemic way by identifying synergies between all the factors and actors working towards it. And one such way is bringing focus to the enabling environment, which constitutes of interrelated sector functions that would have an impact on the functioning of the government. And one such function is institutional arrangements. In order to achieve progress, we need to set performance benchmarks in order to then cite issues and then act upon it. With this background, the aim of the study is a critical assessment of water systems with specific reference to institutions in Ahmedabad. And for that, we have three objectives. The objective one focuses on understanding systems approach to WASH, which includes referring literature on systems thinking and its relation to WASH, followed by referring to various WASH systems put forward by various organizations. The objective two includes answering to what are the various frameworks available to evaluate WASH sector, and after referring to a number of such frameworks, IRC building block assessment tool was picked and studied in detail to take it as a reference point to further carry out the study. The objective three includes developing a methodology for an assessment of institutional arrangement of the chosen ULD by first carrying out an overall WASH systems assessment in Ahmedabad and then a focused evaluation of institutional functioning. This was done by a combination of conducting interviews with relevant stakeholders and corroborating information by secondary sources. The output would be a toolkit to evaluate WASH systems by demonstrating it for the case of Ahmedabad and generating an assessment report. Starting with the objective one, here we are trying to answer what is the difference between systems approach and service approach. And to understand that, the basic difference is that service approach is focused on one-time, one-off activity, whereas systems approach recognizes the complexity of the existing entity and puts recurrent efforts for the functioning of it and has its centrality in monitoring and data sharing. Based on that, WASH system is comprised of various factors and actors influencing the social, cultural, financial, and political dynamics of it. And based on that, various WASH building block frameworks have been put forward by various organizations. Coming to objective two, here we attempt to answer what are the frameworks available for assessment in WASH. Further, in order to assess the WASH sector, there are a number of tools for assessment which can be categorized into various purposes as listed here. They have been mapped to see where it is being developed and where it is being applied. So let's look at category-wise mapping of the same. As seen from the map, the solid I can show the region of development and the hollow I can show the region of application. And as seen, the development of these tools majorly take place in Europe or North America, but are majorly being applied in African, Asian, or Latin American countries. So most of the tools are developed in the global north and is being applied in the global south. However, an ideal scenario would be a tool being developed taking into consideration the contextual scenario of where it is to be applied, and the study is exactly trying to do that. Since the IRC building block framework hasn't been applied anywhere yet and the study is in collaboration with IRC, it is taken as a reference point to further carry out the study. Now coming to objective 3, which forms the main crux of the study, we are trying to answer these three questions. So the first is, what is the approach for institutional assessment? So the approach is essentially deciding upon a set of performance indicators which will allow us to then map the strengths and weaknesses and then identify areas of intervention. And this is being done for a city area of 566 square kilometers. For the water supply household coverage of 98%, that for sanitation is 86%, and that for the city coverage for drainage is 30%. Now coming to the second question, which is what is the framework being used to perform the institutional assessment? The macro level assessment part of the framework includes using the IRC framework to analyze and operationalize it for our purpose, which basically included mapping all the institutional agencies in WASH contributing for the city of Ahmedabad. The step 2 includes for macro level assessment, which includes deciding performance indicators and categories by referring to literature on institutional assessment and looking at what are the good practices in institutional functioning. The step 3 is formulating a questionnaire and deciding upon a set of indicators in order to, set of stakeholders in order to then tap into the decided set of indicators. Step 4 is rating and assessing the institutional performance by deciding upon the rating method for each of the indicators and then also corroborating it from the secondary sources. The result is then in the form of a performance matrix, which will allow us to then identify areas of interventions. The performance indicators are namely organizational autonomy, leadership, developing and maintaining staff, financial health, technical capacity management and administration, public engagement, and interaction with external agencies. So there are 8 performance indicators, 40 sub-indicators, and 70 questions. So each of the indicators has 5 sub-indicators. Each of these sub-indicators are a combination of quantitative and qualitative factors. And then each indicator is tapped into by a varying set of questions in the questionnaire. Now, coming to the result of the institutional assessment from the decided framework. So for macro level assessment, the roles and responsibilities have been mapped for various departments that contribute for war services in the city. And this has been done separately for centralized system catering to non-poor of the city and parallel systems catering to poor of the city. And then coming to the result for micro level assessment, so it has been quantified in categories of low, moderate, and high. So if an indicator is completely in place, then it is high. If partially present, then moderate, and if completely absent, then low. And based on that, by conducting a study, the performance of each sub-indicators has been marked through traffic lighting system. So we get a visual idea of which indicators is relatively doing well, for instance, leadership and financial health, or which indicators has scope for improvement, for instance, public engagement and interaction with external agencies. So from the performance matrix, we get a department-wise performance idea in different areas of function. Now, since these departments are part of ULB function, most of the performance levels across different aspects is similar. However, certain areas such as developing and maintaining staff and management and administration is a departmental level aspect, and hence its performance relatively varies across departments. Overall, the ULB is strong when it comes to its technical capacity, financial health, and leadership, but has a scope of improvement when it comes to public engagement and interaction with external agencies. Now, these mapping then enables us to derive interventions based on identified weaknesses, which can have a varying level of interventions ranging from policy level, departmental level, or ULB level. So the evaluation using the development framework gave an entry point allowing us to come up with broad areas of intervention, which can further be projectized, which essentially is a result of being able to map the performance across identified performance areas, giving us an evidence-based decision-making process. And this will then result in more resilient institutional functioning and hence more resilient on-ground action. Thank you.
Thank you very much. A very interesting presentation. I'm particularly interested in your presentation because I have a PhD student who's actually working on war sector resilience in Iran. So would be very interested to read your paper when it's published. So thank you. Thank you very much. Can we go on? Next one, please. Yes.
Yeah, interesting one. And okay, there are a few questions also coming about the sharing of the PDF file of the presentation. So maybe we have not taken permission from the presenter right now to share the presentation with others, because I believe like many of you also submitted the full papers. So since it is under publication, I think sharing might not be a good option, but we will share the video of the session will be available. Okay, we'll discuss during the Q&A session in more detail. Our next presenter is Arfa. So the title of the session, presentation is Re-Evaluation of Cyclone Shelters along the coastal region of Bangladesh through a risk analysis approach. Let's listen to this interesting one. Yep.
Hello and greetings from Dhaka, Bangladesh. My name is Arfa Islam. I'm from the Department of Civil and Environmental Engineering at Northside University, and I will be presenting our study on behalf of our research team. Our study is titled A Risk-Based Approach of Assessing Cyclone Shelter Location in Bangladesh. Let us proceed. To begin, Bangladesh is one of the most vulnerable countries in the world to tropical cyclones for a number of reasons, first and foremost of which is its geographically unsuitable location. If you look at the map in the top right here, we'll see that Bangladesh lies at the apex of the funnel-shaped Bay of Bengal ocean system, which increases wind speeds as the cyclone moves up the bay. The Bay of Bengal is also a zone of cyclogenesis, meaning cyclones form very regularly in this location. The coastal region is very flat, very polar protected, and of very low elevation. In addition, climate change also plays an important role. Rising sea surface temperatures and sea levels have amplified the impact that cyclones have had on the country. And lastly, the coastal region itself is very vulnerable. Bangladesh is home to one of the largest coastal populations in the world, with over 50 million people who are among the poorest people in the entire country. The cumulative result of all of these are devastating. Here we see the destruction that was caused in the 1991 Gorky cyclone, which left 300,000 people dead. All in all, over 1 million deaths have been caused by cyclones in the region. Now, to save lives, the government and various NGOs have taken the initiative to build cyclone shelters. Cyclone shelters are multi-storied buildings and structures made of reinforced concrete, such as these we see in the images below. If you look at the graph here, we can see that in the aftermath of the 1991 cyclone, there indeed has been a remarkable effort to construct cyclone shelters, and at present there are over 6,000 shelters in the country. In the right, we have the historical overview of cyclones in Bangladesh. The top graph shows the cyclone-related deaths on a logarithmic scale, and we can clearly see that the number of cyclone deaths in recent years is significantly lower than it has been in the previous years. This is in spite of the fact that recent cyclones have had wind speeds and storm surges which are as great, if not greater, than those in the past, which have been much more deadlier. So clearly, the cyclone shelters are having a positive impact. Yet, despite this commendable progress, cyclone shelters still accommodate only 5% of the coastal population, so new cyclone shelters need to be built. However, previously there has been no scientific basis for selecting where these cyclone shelters should be located, and it was done mostly on the basis of the judgment of experts or through the demands of the locals, and no study has really tried to address this issue. So to maximize the effectiveness and to maximize the resource utilization, there needs to be a scientific study to reevaluate the placement of cyclone shelters, and this study aims to achieve exactly that. This study will mainly have three objectives. Firstly, to conduct a cyclone risk assessment of the coastal region of the country through a risk matrix. Using this, we can identify which locations most urgently require capacity. And lastly, we can propose a plan for the placement of future cyclone shelters along the region. This study has been conducted on an Upazila level, which is roughly equivalent to the sub-district level, where we apply what is known as the HEVR model. We use data from a wide range of secondary sources. The methodology we have applied is as follows. We use a modified approach that is based on the HEVR model that was first put forward by the UN IPCC in their SREX report in 2012. It is suggested that disaster risk is a function of three separate elements: hazard, exposure, and vulnerability, as shown in the diagram here. In a particular scenario, if any of these three elements are missing, we can say that there is no risk, and likewise, if all of these are present, then there is a significant risk. In addition to this established idea, we have further identified that disaster risk can be offset by the capacity of the people to withstand and recover from the impacts of the disaster. However, the main problem is when this disaster risk greatly outweighs the capacity, as shown in this diagram here. In this case, even though risk is somewhat mitigated, there is still a significant amount of risk that is remaining, and this remaining risk will translate to death, damage, and loss in the case of a disaster. So what we need to do is we need to mitigate this remaining risk. We need to further build capacity that will allow the community to fully withstand the disaster, and so that capacity and risk can fully offset one another. This is the basic principle that serves as the basis of our entire study. So what we did was, for each element of risk, H, E, and P, as well as for C, there are a number of components that serve as parameters. We have assigned weightages to each of these components, we have normalized the attribute data, and we have categorized them from 1 to 5 so that we can develop a risk matrix. Here are the components that we considered. For hazard, we mainly considered cyclone-related factors. For exposure, the main factor was population density, as well as a few other factors related to exposure. For vulnerability, various socioeconomic and demographic factors such as poverty, income, and education were considered. And for capacity, we looked at cyclone shelter and pakka houses, as well as embankments, roads, medical centers, growth centers, and rural markets. Here are the results of our data analysis. Firstly, we note that H, E, and V do not affect R equally, so we assigned weightages following this scheme. We should note that there is no fixed formula on the basis of which the weightages should be assigned. So what we did was for each case, we consulted various experts, we reviewed available literature, and we used our own judgment as required. Here is the risk map, which was derived from the hazard, exposure, and vulnerability maps, each of which were derived from their respective components. For each, you will see that there are a number of qualitative descriptors, and each of these correspond to a numerical value from 1 to 5. So very low is equal to 1, low equal to 2, moderate 3, high 4, and very high 5. Likewise, we have derived a capacity map. And what we have done is we have done an analysis for each Upazila based on risk and capacity. Here we introduce a new term called need. And this term is synonymous to the previous term called risk to be mitigated. The main idea is that for locations which have very high risk, they should have very high capacity, and likewise, locations which have very low risk can do with very low capacity. However, when capacity is lower than risk, that is when there is a need to increase the capacity. Because both risk and capacity are done on a scale of 1 to 5, if we take the ordinal values of the risk level and subtract the ordinal values of the capacity level, we will get the values for the need level. And this map here represents this exact thing, the need for capacity. And we have the need varying, ranging from very urgent, which is a level of 4, meaning basically we have very high risk and very low capacity, all the way up to no present need required, meaning the risk is equal or less than the capacity. So we can see that a significant number of coastal upazillas, 57 of the 128, need for the capacity. And here is the breakdown of the coastal upazillas by how much they need capacity. Here is the last part of our results, which allow us to fulfill our ultimate objective of determining where and how many cyclone shelters are required. Here we have a list of upazillas, its risk, capacity, need, as well as the present number of cyclone shelters and its present coverage. For each upazilla, we have identified the number of cyclone shelters that are required to increase the capacity by a certain level and thus to reduce the need by that same amount. For example, for this first upazilla, if we add 20 cyclone shelters, the capacity will increase from very low to low, and thus the need will go down from very urgent to just urgent. Likewise, if we add 46 cyclone shelters here, the capacity will increase further from low to moderate, and the need will go down another level. And if we add 64 cyclone shelters, the capacity will go up another level, and the need go down another level, and so on and so forth. Please note that this data table here is a truncated version of our entire data set. The purpose of this was to just demonstrate how our framework functions. Lastly, we determined these values by taking a reverse approach. We fixed our formulas and our algorithm, and for each upazilla, we kept adding cyclone shelters until we saw the level of capacity increase to which we have desired. So in all, this is the method that we propose, and this is the method that we use to determine where cyclone shelters are most required. So in conclusion, Bangladesh is very vulnerable to cyclones, and cyclone shelters play a big role. However, there are limitations in terms of the capacity as well as the distribution of cyclone shelters. This study adopts a scientific method based on an established model with some innovations, and an algorithm was prepared to determine which location needs cyclone shelters the most. We hope that this study establishes a framework that will help the government choose appropriate locations in the future for cyclone shelters. And lastly, an extensive field visit to understand the present conditions of the cyclone shelters, including structural features, facilities, and need for improvement, will be done as soon as circumstances permit. That brings us to the end of our presentation. Thank you very much.
Thank you. This is a good piece of work. I think I'm very interested in this topic, but I was just wondering, and I just have a question. You don't have to answer now. We can get back to during the discussion. Is that when you're talking about risk, are you only talking about the cyclonic wind impact, or are you also considering the storm surge, the accompanying storm surge that comes with the cyclone? Because I think that is sometimes more devastating, and perhaps it has even long-term impacts by inundating large pieces of land and not draining out for years. So anyway, I could talk a lot about this topic. I did a lot of work myself. So, but let's just go on to the next one. I think we can come back to it during the discussion. Thank you. Thanks very much.
Yes, I also agree with you. There are quite a lot of issue on the cyclone shelter selection, site selection, especially in the entire east coast of India and Bangladesh, completely. So I think that there is a lack of mapping the risk and the exposure analysis also. So that part maybe is interesting to understand from Alpha, how we have evaluated. Okay, so we'll discuss all these issues just after one presentation. So our next presentation is by Manoj Kumar Kini. So the title is A Working Strategy for Preparedness in Kerala Schools, a Suggestive Study. Let's see. Yes.
Warm wishes to one and all present here. Hope you are healthy and well in these difficult times. We sincerely thank DRSD 2021 for giving us this opportunity, and we are glad to be a part of this symposium and this presentation series. This is paper code DRSD21_204, a working strategy for preparedness in Kerala schools, a suggestive study, is authored by Dr. Manoj Kumar Kini and Amrita Vinod. Children are the vital resources of a country and are the most vulnerable group exposed to disasters and various safety issues. Schooling takes up around 13 to 15 beginning years of a child's life, and this compels us to examine the level of preparedness in schools of Kerala. Kerala, with a total of 34,72,955 children, as per the census of 2011, is spread over 38,863 kilometers at the southwestern coast of India. Kerala is a narrow strip of land between the Western Ghats and Arabian Sea, with a high population density of 860 people per square kilometer, and is one of the most vulnerable states in India. The region is multi-hazard prone and is exposed to a wide range of disasters. In addition to the nationally notified disasters, the state identifies the state-specific disasters such as coastal erosion. The table lists out the identified hazards in Kerala. School safety is focusing on creation of safe environments for children, starting from their homes to their schools and back. This research critically examines the preparedness of schools in Kerala in handling disaster and works out strategies to combat any instances of a disaster. Kerala schools are marked for their excellent academic performances but have poor awareness of safety and preparedness. The unsafe school transportation is one such example proving the same. The study suggests managerial, strategic, and implementation level policies for building safer, better school environments in Kerala by analyzing the current strategies exercised for. After understanding the context and the need for review on the subject, the study analyzes the existing school safety guidelines at national, district, and school levels. Furthermore, the study analyzes the state disaster management plans with the national school safety policy to elicit inferences leading to the conclusion. In the state, there are about 12,644 schools in total, in which 4,504 are government schools, 7,277 are aided schools, and 863 are unaided schools. Malappuram has 1,379 schools, which is the highest in the state, followed by Kozhikode and. Apart from the natural disasters, the most prominent hazards in Kerala schools are accidents caused by fire, electrical services, transportation, sports, excursions, unsafe food, exhibitions, festivals, and other man-made issues such as slips, trips, fall from heights, falling objects, and construction. The National School Safety Policy identifies 5 action areas: strengthening institutional commitment, planning for safety, implementation of safety actions, capacity building for safe schools, and regular monitoring of risk and revision of plan. The table shows the roles and responsibilities of different stakeholders. In Kerala, a school safety advisory board under the state disaster management authorities advises at both state and district level actions. The district should monitor to ensure. Each district designates a block level officer to manage block level activities and efforts in school safety. The district education officer holds the responsibility to check if the recognition certificate is issued to schools that comply with the safety norms. The school management is responsible for developing disaster management plan and taking on safety agenda in the school community. The school disaster management plan and analysis. The analysis is done by comparing and contrasting the school disaster management plan models by National Disaster Management Authority and Kerala State, referring to more than 28 school disaster management plans in Kerala published on State Disaster Management Authority of Kerala website. From the above analysis, we can understand that the centralization of roles and responsibilities at district and state levels of governance leads to lack of systematic actions and delays. There is a lack of awareness, knowledge among stakeholders, resulting in loss of impetus. The gap between vision, operation, and achievement of goals reveals an inadequate grassroots level actions and need to work on base level activities. Large numbers of schools and a huge school-going population demand strong control points at local level government bodies. There is a lack of transparency in the system which restricts the public from understanding the degree of safety ensured by the school. The degree of safety, preparedness, and its operation have to transform into major monitorable indicators, creating the schools in their recognition and accreditation. Lack of periodical reviews, audits, and documentation deters proactive actions and timely revision of plans and reinforcement of action plans. The school safety plans lack the directions of emergency situations, audits and quality checks of services, and also do not address the possible mental physical harassments in schools. School disaster management plans do not sensitize the fundamental components of school preparedness, leading to lack of awareness among users. The plan should also adequately address differently abled students with training, explanation of steps and procedures for safety at the time of emergency. School-level governance should ensure working plans, procedures, and timetables to carry out systematic school preparedness activities. Loose connections of different levels of governance and dilutions of responsibilities leads to unsustainable, unproductive, and effective use of resources in school preparedness. The history of safety in Kerala schools drives to a conclusion of having a participatory or collaborative operation from the grassroots level through the solid local self-government networks having 1,200 units. The institutions like KILA, Kerala Institute of Local Administration, an autonomous institution functioning for the local governments in Kerala, can also be brought into the base tiers of school safety preparedness for collaborative efforts as a step towards a decentralized planning and monitoring efforts, training skills and developments, ensuring effective participatory efforts in school safety with optimum resource utilization. School safety preparedness should be understood as a continuous process rather than one-time effort. Hence, decentralizing the roles and responsibilities with the help of local self-government networks of Kerala will decrease the gap between the vision and the operation. The research, a suggested study, proposes the collaborative and participatory effort for a better, safer, disaster-resilient and responsive school environment in Kerala. Thank you so much for your patience.
Thank you. Thank you very much. Very interesting. I mean, once again, you have demonstrated how Kerala is a leader in amongst the different states in India, and in many respects, they are leading in terms of education, health indicators, and all kinds of, renewable energy. I think that is fantastic. This is also another example how, and what I was wondering at the beginning of your presentation is how much interaction there is, how much participation there is from the stakeholders, the school body. And I see that you have clarified it very clearly that it is a collaborative participatory process, and that is how it has moved forward so well. So thank you very much. Very interesting. Thanks. Want to add anything, Indrajit, or shall we go on to the Q&A?
We can go to the Q&A. There are in very interesting response. Actually, I was following the chat. So all participants are also welcome to ask questions through chat box. And please.
Yeah. Okay, so let's just go right back to the beginning, and I will start looking at some of the questions, and we'll come back to the later discussions which have started becoming more enriching rather. So firstly, there was a question to the first presenter, which was, I think, Nguyen Chao Lan. And what he said is that this is somehow quite relates to what I was also thinking, that do you have you reviewed any previous studies, and what was the performance of such uses of waste-based aggregate for road construction? I think that kind of relates to my question also, which I was asking about what's the cost-benefit analysis. Have you looked at the literature and seen that how much, weight does your proposal carry? So you may respond to it if you want. Lan? You can unmute yourself and talk on the camera if you want.
Participant switch on.
I think the moderator, you may have to give them the rights.
Yes, I mean, it's already on. I mean, participant, please try those who want to respond, participants, so they can switch on their mic, can unmute their mic.
Maybe he left. Lan, are you there? No, he doesn't seem to be here.
Yeah, it's okay. We can move to the next questions also.
Okay, That is a good question, though, Mr. Muhammad Shirajul Islam. I think I concur with your question. I would really like to know that too. Okay. The next question, very insightful presentation, Malit. Okay, question for Mr. Senaviratna. It is still not clear to me how we can use this conceptual framework to decide what actions we should take when the consideration based on tsunami and the consideration based on pandemic risks deliver different recommended actions. Can you elaborate a little bit more about how actions will be recommended? And I think, Malit, my question also, it's similar. I think what you have done is very interesting, this interaction between bio and natural hazards. And this is a very important topic. UNSCAP is just coming out with its new disaster report. And this is something that they have captured there. And it's not only tsunamis, cyclones that happened in East Bengal, West Bengal and Bangladesh recently. They also had the same issue. What happens, this confluence of COVID together with natural hazards. So I think, yeah, you can go for it. You can answer. Thank you.
Thank you very much, and I really appreciate the question that is raised from Dr. Kalpana, as well as the elaboration that you made in this arena, Mr. Ahmed. What influenced me to this research is mainly due by the guideline that is issued by the IOTW regarding the tsunami evacuation during pandemic, which raised the interest of myself for this research, which sort of conflicting, because during the pandemic situation, we were all raised and embraced this physical distancing as the major preventive measure. But when it comes to disaster evacuation, that is not possible to maintain because when we have this life-threatening situation, people always tend to move towards safe locations, irrespective of the physical distancing or this slow movement. So how we can manage the situation at a root level, rather than managing it at a concentrated clusters or managing it at relief locations, how we can manage it at a road level. That is where I'm going to explore in my research. So basically, I'm utilizing this centrality concept as the road analytical component because with the literature have been with the literature findings that basically that is what is the output of this conceptual framework, that there are certain a compatibility of centrality concept, which is the measure of connectivity in the city with the pattern of pandemic transmission, especially when it comes to the COVID-19, the cities where the connectivity is high, where we find more agglomeration of communities are the places where pandemic outbreak was happened. So that relationship is obvious, where connectivity is one of the influencing factors for pandemic. So, but still that relationship is not properly explored and not implemented when it comes to disaster evacuation. So that is where I'm going to intervene with my research findings. So centrality as considering as an analytical component to find a relationship between how a pandemic can grow when there is a disaster evacuation situation. And then so if we can identify these routes as clusters, so that we can distribute the relief locations rather than concentrating the population into one relief location. We can have multiple relief locations combined with vertical and horizontal evacuation, so that there can be population, the evacuees can be clustered into small centers, which could be a potential approach to minimize the cross transmission between communities, so that people we can easily monitor and then keep them restrained into a small clustered locations, so that a pandemic or a contagious disease transmission can be minimized. So for this, I have identified this compatibility with centrality as a potential approach, which I'm going to explore. And this research is kind of the theoretical background for my study, where I have identified this contrasting and compatible factors, especially to going through risk identification, risk assessment, and then when it comes to risk management, risk reduction implementation. So that is how my research will flow on, and I'm still at the stage of collecting data and moving towards my analytical process. So this These findings will help me to formulate the final framework for identifying the tsunami evacuation and safe clusters.
This is very good. This is interesting. I think what you're saying, I'm thinking that even on a day-to-day regular basis, it's challenging to implement social distancing and management of, movement. So, and in a disaster situation, of course, we call it in Australia super spreader events, and super spreader events can be disasters of different kinds when people are clustered together because of necessity. The other thing also is they remember that there are different virus strains which are much more contagious. Now there's the new Delta strain, which is very rapidly contagious. So I think it just complicates your work. I think it's not an easy job for you to, but so good that you have taken on board this difficult task. So thank you.
Thank you very
Thanks
much,
very much.
Ahmad. Yes, I really appreciate the opportunity that have been given to me. Thank you.
You want to add something, Indrajit, to that discussion?
Yeah, no, already you mentioned. So I was sort of wondering like how the cascading part can be considered in your study. Like there are multiple hazards right now we are facing, especially in Bangladesh and the East Coast. Recently in 1 year, we have seen during the COVID time, we had like category 5 cyclone struck 2 times in 1 year. So that also is one of the concerns, like not only COVID, there are multiple hazards can start at the same time, or maybe there are. So these are the few things maybe can be discussed further as well. But I can see if there are quite a good questions also for Arfa Islam, and Arfa Islam is here present. So
yeah, I think what we may need to do is that Arfa has actually responded quite well to many of these questions. There's no sense in plowing over that ground. I think what he has actually clarified is some of the concerns that we had about his methodology in terms of the kind of risk factors that he took into consideration. He's answered that quite well. Then I think there were other questions from Nin. It's about capacity, and he has actually clarified it according to the exposure and how close you are to the source of the hazard. And based on that, is capacity assessment, the closer you are, more proximity is your, risk factor. So that is good, I think. I think there are many other issues, Arfa, I can talk to you. I think just to give you an example, the island of Pula, as you know, it's expanding. Even though we're talking about sea level rise and land being lost, but because of sedimentation coming in from the rivers, and it's accumulating at the mouth of the Ganges Delta, and tagging on at the bottom of these islands. So what had happened, Chor Fashion, for example, when they had built a cyclone shelter there in the 80s, now that's nearly 100 kilometers away from the coast. So it's redundant. You see, so there are all these factors. Partly, I think whenever you're doing work in a dynamic in the sense that the land, the deltaic topography is dynamic. It's changing all the time because of all kinds of, and it includes the adjacent West Bengal state where similar kinds of, phenomenon is going on. So every time you do that, whatever you're doing is a snapshot in time. In 10 years from now, because of climate change impacts, as well as the dynamic nature of the topography, these factors would need to be reconsidered and reevaluated and rethought. And so I think it's a good piece of work that you have embarked on. It's very useful, relates strongly to the Sendai framework's first priority. We actually skip that priority quite a bit and move on to the other ones, private sector incentivization and holding the governance accountable, and that kind of stuff is the preoccupation of a lot of the policy frameworks. But I think that is very important. Unless we have the knowledge where the risk is, we cannot actually target action. So that's great.
If I may add something to this discussion.
Certainly.
Thank you, Dr. Ahmed, for your comments. Firstly, there is obviously a degree of subjectivity in terms of the work we did. The factors were considered. There's no fixed formula. Even according to the UN, there's no fixed formula. We had to consult various sources, do extensive literature reviews. But the main target of this is to at least establish a framework which gives us a rough idea of where we need to place the cyclone shelters. In the past, the way it was done very in a random, haphazard way. There was no real It was just done on the judgment without any scientific basis. So this is the first step to addressing that. And obviously it needs to be updated. For example, an obvious limitation, we use the 2011 census. The new census has not been out yet. It will come out hopefully later this year. So obviously then we'll need to reevaluate the vulnerability factors, population, income, etc. So the main idea is to at least have some scientific basis in terms of where we're going to place our shelters. In many ways, our country is very lucky. The last two big cyclones, it just grazed our country. It didn't actually go through the heart of the most vulnerable or the most at-risk regions. And in the future, there are plans for the government to build a new batch of several thousand shelters. So I think this study would coincide well with that timing. So they could perhaps look at a methodology such as this so that they would have a better idea of where to place their shelters.
Yeah, I think your main contribution is the methodology, the systematic approach to addressing the risk assessment process. So that's good contribution. So thank you very much. I think we have run out of time, haven't we?
Yes. Okay.
I think
Thank you, guys. It's a really interactive session. Just to inform you one more thing. Since the discussion is going on very well, all of you who are willing to join the discussion, continue the discussion. So you can go to the Padlet and also the networking place. There is a separate Zoom link and it's active. So you can directly go to that chat room as a networking place. So you can discuss and clarify. So it will be open, until another 4 hours. So anytime you just jump in and discuss your issues, and then I think this is a great networking place you should explore. And it will be also open for another 3 months for a few hours every day. So that's the place actually you have created for you to continue the networking and learn from each other. Thank you. Over to Ipti.
That is good. So thank you very much. I think I have learned a lot from this session, and it was a good mixture of quantitative and qualitative presentations. And I think the binding factor within all these is that you're concerned about, risk reduction, reducing resilience in various ways, at looking at the minute figures, the numbers that actually contribute to the behavior of materials and behavior of structures and so on, to more holistic, human-centered kind of approaches, school safety and grassroots approaches. So I think you've covered a good, reasonable ground within this session and kind of pertaining to the topic of the session. So I commend all the presenters for their excellent presentations and their contributions, and wish you all the best in your work. And some of you have embarked on certain journeys, and so hope the journey is going to be fruitful and productive at the end of the day. So thank you. Thanks very much.
Thank you so much. We'll come back in 10 minutes after break, and we'll move to technical session 18, multi-hazard risk and governance, for the next session. So, okay, thank you so much. So we'll take leave from this session, and we're closing this session. Break for 10 minutes. Thank you. Thank you, Ifti, also.
Thank you very much.
See you